Bonjourni. Oh, I should close some of these things. Quit. All right, here we go. Here we go. Here we go. Here we go. So systems of equations and of inequalities. Systems of equations. And these are going to be non-linear equations with some linears and stuff, okay? So here's our objectives. Recognize systems of nonlinear equations in two variables. Recognize. Solve this nonlinear systems by substitution or solve them by addition. And then we can solve problems using those. And if we get time for that, then yay. But the first two are going to be the important ones. Okay. Wait. Here I go. Systems of nonlinear equations and their solutions. Thank you. So, a system of two nonlinear equations and two variables, also called a nonlinear system, is going to contain at least one equation that cannot be expressed in the form of ax plus by equals c, which is your standard form of a line. Talking about the solutions. If you do have a solution like that, you're going to get a couple different possibilities just as before. You might get no solution. You can get one solution. And if you're talking about circles, maybe you can get two solutions. If one's cubic, you might get up to 3 solutions. If it's quartic, you might get up to 4 solutions. So the degree of the other equation is going to determine the total number of possible pretty much solutions. Make sense?
Yes.
But we're still also looking for the sets of solutions that would make the system true. Okay? And you'll learn to see the different scenarios there. And of course, the solutions are the intersections of the two graphs. That has not changed. All we're changing is the degree of the polynomial that we're working with. Okay? Cool. All right, here's an example. In this case, we see that we have x squared equals y minus 1. X squared should tip us off that we're working with a parabola, a quadratic, right? A parabola. So here's what can happen with our parabola. You could probably have a line that crosses it as such, therefore providing you with how many solutions? Two. Which is called a, what type of line? You guys remember? You remember? A secant line? Is it secant? If I remember correctly. You can also get it where it is tangent. Oh, I missed it. I missed it totally.
He's like it's touching, okay?
Let me try the bottom part. Let me try the bottom part. So, fa. So where it's tangent, where it only crosses one time, or like my first example where I totally missed it and it crosses never. Okay? So, here they want us to do it by the substitution method. They want us to do it by the substitution method. So, I can see, and how you go about it is totally up to you. I'm going to take advantage of the fact that x squared is equal to y minus 1. And if I move this over, 4x is equal to y minus 1 as well, isn't it? So through the transitive property that you remember from geometry, I can say, hey, you know what? 4x is also equal to x squared. Yeah? So now I can go and use my zero product rule, where I've got 0 is equal to x squared minus 4x. 0 is equal to x times x minus 4. Therefore, I have two possibilities for x solutions, don't I?
Yeah.
What are they?
0 and 4.
I've got 0 and I've got 4. So there's two x's that I can test. And what I'm going to need to do to get the y's is to plug them in, right? So let's go to the let's go to the top one. X squared is equal to 0 minus 1. Oh, that's not nice, right?
No, because you'll get.
Will that happen with the other one as well?
Yeah, but it'll be a little.
If I do,
green.
let's try the other one. I've got negative y is equal to negative 1, so y equals 1. Yes?
Yeah. Shows 0.
Yeah, well, x is 0, right?
Yeah.
So that's gone.
So you get 4 times 0. Like,
Correct?
1.
So there's a 1.
Yeah.
Because I'm saying that x times this is equal to 0. So if this is some number, and this is some number, then one of the two has to be 0, right?
So 0 is right because if you plug in the top one for x,
It's also true, isn't it? Okay. And then if I plug the 4 in for x, let's do that real quick count. I got 16 minus y negative 1. Take away 16 on both sides. Negative y is equal to negative 17.
Yep.
Which means y is also... Where did I lose you? No, go ahead. Please. Everyone's okay with 17 being the other one? It's not necessarily gone. I use it to substitute. Let me show you what I mean. I'm going to get rid of this. Woohoo, that worked, yay. So here's what I know. I know that x squared is equal to y minus 1, correct? That's the top equation. Now this equation, I modified it, and it says that 4x is equal to y minus 1, correct? All right, so here's the idea. X squared equals y minus 1, and if I write this backwards, it says y minus 1 is equal to 4x, doesn't it? So here's what the transitive property says. This is equal to this, right? And this is equal to this, and this is equal to this, therefore this is equal to this. Math. So, x squared is equal to 4x, and then I went in and I solved it as by factoring. And I found that the two possible x's based off of this factor are 0 and 4. And then I just plug those into the second equation to get the y values that correspond to that. Okay? Merrick Trench? Which part do I need to explain? Well, you say it like that, and I feel like there's still questions, and I want to answer them. Yes? It gave me something weird, didn't it? What was it? it was 0 is equal to y minus 1.
Yeah.
No, it was fine. It was fine. Because then I would have to kick that over, and it would be a 1 again. I'm not sure what I did. It was weird.
I don't know what you did. X squared equals negative. Oh yeah, because you put the 0 for the y instead of.
Oh, I put the 0 for the y instead of the x. Yeah. My bad. I make mistakes. Now, was that the only way you could have done it?
No.
No. You could have. Oh, I thought I got it. You could have also have done elimination. Elimination. X squared minus y is equal to negative 1, right? And then we've got 4x minus y is equal to negative 1.
Yeah.
Now, if I could get those y's to cancel, if I changed this to be negative 4x plus y is equal to negative 1. Right? Well, not negative. Positive 1. Thank you. So I could have done that, right? So at this point, y and y cancel. And if I add the two equations, I've got x squared minus 4x is equal to 0. And there it is again. So math doesn't change. Still the same rules. People change. Math doesn't. Math only gets better. It's like, oh, can't say that one.
He's like, can't do that.
Well, you know, cheese. It's like cheese. The older the better. Okay. Are we cool with this? Not so bad, yeah? Now, I got the two solutions. What must I do after that? Yeah, check them. At this point, I mean, these are great because if you're testing and you're not sure if you did it right, if you check it and it works, then you're good. You've got like double check.
And if you check it and it doesn't work,
Then you better go back and see what's going on.
what if we run out of time? Then we're screwed. Just tell you whenever you can.
Okay. Can I change the slide? Are we good? We're done with this slide? Okay. So I'm going to. Whoa, what is all this?
Yeah, it's all the same thing you just.
So there's 1, 2 slides, 3 slides, 4 slides.
Yikes.
What were we at, 6 now?
Oh yeah.
All right, go. Here's the next one. All right, so here's another one. They want us to solve it. Whichever method you like the best, go for it, right? If you like substitution, do substitution. If you like elimination, do elimination. Personal, all right? No. You cannot, not with nonlinears. Not that I know of yet. Maybe you will invent it. Now, yeah, now we can't. I'm sorry. Okay. Which method do you guys want to do this one?
Elimination.
Because you can do either way. It doesn't matter.
It seems easier if we do elimination.
Okay.
Get rid of the lines.
Huh? So for linear combinations, aka addition, aka elimination, we want somebody pick x's or y's. Y's? Why y's?
Because they're smaller.
That's a fantastic reason. If you said because it looked right, then that's even cool too. So here's what I want. I want these two to be opposites of each other. So I'm gonna want to think of the. We're going with the y's because someone said y first. I want to find like what is like the LCD
6 is the LCD.
kind of thing. So I want it's gonna be 6. So I want one to become positive 6y squared. I'm gonna want the other one to become a negative 6y squared because when I add them, I want them to add up to 0. Same process always. Remember how we did the 3x3 system? You had to do 2 and then 2. All right, we'll talk about that one later. But it's 2 and then 2. So hopefully we don't get that. But anyways, let's do this one for now, okay? Everyone okay with the 6y squared and the negative 6y squared? What did I do to the top?
Multiply it by 3.
By 3, so this is going to become a 9x squared equals 105? Yeah? Cool. Bottom was multiplied by 2. So I've got 8x squared and I've got 96?
Negative 8x squared, negative 8.
Oh, it's got to be a negative 2. So negative and then negative there, right? Cool beans. So now I've got x squared is equal to,
9.
so x is equal to plus minus 3. Plus minus 3. So I know one's a 3 and the other's going to be a negative 3. Okay? Now, if you don't recognize those, you're looking at 2 circle-looking things. Yeah, so they're going to cross each other somehow like this. So there should be 2 solutions. And they're circles because they're both squares. Right? Cool. All right, so let's go figure out what our other values are. Let's go with this one.
Yeah.
So this is 9 times 3. This is 27, correct?
Yeah.
3. So that's 27. 35 minus 27 is 8. Divided by 2. Y squared is equal to 4. So that means that y is equal to plus minus 4. So I'm going to get
Wait, plus minus 4 is plus minus 2.
2. JK. So 2 and then negative 2. And if I do the negative 3, it's the same thing.
Should be. Yeah, it'll be the same thing.
So I would get a
2 and negative 2 again.
2 and the negative 2. So there's 4 of them.
Well, that would make sense though, because you have your the degree of your equation is 4.
Well, what should I do? Should probably check them.
Yeah.
Take those, plug them in, see if they work. For the top one?
Yeah. Both of
For
them.
both of them. All right. Okay. Copy that down. Yeah. Why so serious?
Wait, so all 4 of them?
That's your solution set. Yeah. In this case, they all work.
For the top one, yeah.
Yeah, I know. That's what I said. Yeah.
Why didn't you just do y squared or 2y squared? Can you just like let it let you know like
Why did I just do 2y squared? Because we saw this was 27, right? So we did 35 minus 27 and got 8. So we just kind of skipped that step. Our bad. My bad. Me and Tomas.
Oh my goodness.
Sorry.
Tomas and I.
Yeah.
It don't matter. I don't care. It's math, not English.
I don't like English. I haven't had it.
I can't hear you. Hold on. Let's wait for some professional courtesy here. Well, the first thing I got was 3, correct? The first one we got, the first time we got 3 and negative 3, correct? So I made 2 sets with 3 and negative 3. Then when I plugged in the positive 3, I got 2 solutions out, which were plus minus 2. So that means I had to make another one. See that right there? That had another positive 3, but that went with a positive 2 and the other one with a negative 2. Then we went back and we plugged in the -3, and we said, well, that's just going to be the same thing because a negative squared is still positive, isn't it? Yeah. Yes. You must.
Wait, how would you check it?
You would just plug it back
You
in.
plug them back in. Make sure they're true statements, right?
Yeah.
But how would you know which three? Oh, so
They will all work,
Oh,
right?
you would plug both in. Okay.
They would all work.
Yeah, they all work. They all work in the top equation.
Wait, so it's all four of them that are?
Yeah.
Yeah, because you just plug them into both equations to see all of them.
Which is kind of trippy because I can't see how two circles. Oh, they're not circles.
They're not.
They're ellipses.
That's
They
what
have
I
a
was
little
thinking.
thingy.
They're ellipses because if they were
They have to
circles,
be like this.
then there wouldn't be these coefficients there, right?
Yeah.
Yeah, so these are ellipses, which makes sense because ellipses that cross each other will do this, and you'll have 1, 2,
3, 4.
4
Yeah.
solutions.
I just thought about that right there.
Remember, if they're circles, it'd have to be x squared, y squared,
And
with the
wouldn't-
radius squared.
And wouldn't that be square two gives a circle?
Technically, yeah. You could still get a nasty square root, but there's coefficients in there, which means you're gonna end up dividing by the solution, so that you get that x squared over a squared
Yeah, they all work.
plus y squared over b squared equals 1.
They all work.
Yeah.
Wait, what did you say?
Yeah.
Wait, what did
You guys ever remember your conic sections from last year?
I kind of
I would like to forget those.
We had Rosin together.
Let's leave that banana alone. It's starting to look like a chile relleno. Alright, can we move on? Yeah, I was thinking like, how are two circles going? No, they're not circles. Alright, moving on. Moving on. Oh, come on.
That's just step.
Why does it seem like so much here?
Because it's now you're writing.
Ah,
What the hell is
there you
this?
go.
Oh.
Applications. Find the length and the width of a rectangle whose perimeter is 20 feet and whose area is 21 square feet.
What the hell?
What? Watch your words, bud. I'm gonna have a swig of water. I'll let you guys try that for a little bit.
Okay, so it's got a perimeter of 20. So perimeter is equal to length times width, which means it could be 4
Question.
things. My bad.
How many equations should you get?
2.
One for,
X.
one for,
Perimeter.
yes.
And then area is equal to length times width times height. Well, the perimeter can be 2 things.
That's what I should name my child. I should name him Pistachio. Pistachio!
But wouldn't they shorten it?
To what? I can call him Pistachio.
You call him stash.
Nice mustachio, Pistachio.
While you're perimeter is length times width, right?
Perimeter's 2 L's is 2.
Oh yeah. What? Wait a second.
That's what I have so far.
That's what I have too, but with L and W.
Yeah, I was confused for a second.
I got it.
That makes sense, right?
Yeah.
Anybody have questions on those two equations?
Is that all we do?
Thumbs, where are my thumbs? No, solve it.
We have to solve it.
Good, good, good. Alright.
But like, there's not really except well, that's 21 divided by.
Does it? Why is it xy equals 21?
Because base times height.
Base times height is equal to area. And for perimeter, 2 lengths and 2 widths makes a
Oh,
perimeter.
wait, so it'd be 2 and then.
Right?
And it literally says perimeter.
I even underlined it.
2 and 5. 2 and 5. It had to be 2 and 5.
No, you didn't.
Because
You're a liar.
in order to get 20 you have to
Liar.
do 4 and
Liar. Liar.
4 and shit.
Fucking liar.
What?
Liar.
What are we doing Monday?
I won't be here on Monday,
Well, for length and width, for the exercise here. But what about for the rest of the
you can grab this. I'm so happy. Don't make things harder for yourself, just guess.
7 and 3.
No! I don't be guesstimating. I algebra.
That's not estimating.
Multiply together.
It's called common sense logic.
You think things really hard.
You guys factor too much.
You can grab this. I'm so happy.
Light work.
Sorry.
Yeah, it will always work.
I know, it's my favorite thing.
There's actually, you might, so when you get to college, you might like the courses that have the graphical approach. They are though. Alright, anyways. Everybody else, everyone okay with me making the top equation y equals 10 minus x? Y is equal to 10 minus x, so I'm going to go over here. X times 10 minus x is equal to 21.
I just did what you did.
10x minus x squared is equal to negative 2. That means
Where did you get 10 from the 20?
x squared minus 10x minus 2.
What I did over here. What?
Did I do that right?
Wait a second. Wait, I don't. It's 21. Where the hell did you get the 2 from?
Oh, that's why. Thank you. So, just to point out what you guys did, this is a quadratic that I'm going to factor.
Oh,
And I'm looking for two numbers that multiply to negative 21 and will add up to 10, which is 7 and 3. That means that x should be 3 and... Well, yeah, but you want to show the math.
Yeah. That was funny to me.
So your x's would be 3 and 7, right? Yeah. And then we just put those into there.
So if I move x, you get y equals...
Well, we didn't do this.
x and y equals... No, it's supposed to be 21.
Yeah.
Why did you make it equal to 21?
Because x times y equals 21, so you plug in y for in the other equation.
Huh? I can't hear this question.
Why was the negative x squared now positive?
It is. Right here.
Yeah, why is
Except
it
y.
positive now?
Because it was negative on this side. And I moved it to the other side of the ugly equal sign.
Isn't the 21 positive then?
Yeah, why is it negative?
I don't know, then that means that your,
Wait, your solution is still correct?
yeah, your solutions are still
Hold
correct.
on. Good point.
Well, you added them. Well, no,
That's why you're a little confused. All right, let me go here again. Go away.
first you,
Okay. So here's what I know.
plugged in y for.
I know that x times 10 minus x is equal to 21. I've got 10x minus x squared is equal to 21.
You added them on both sides.
Right? That means that x squared minus 10x
Equal to 20
plus
plus 21.
21.
That's equal to 0. Yeah, you still got the right answers. They're still going to both be negative.
Oh yeah. Yeah, they're still both negative because negative makes positive.
Yeah.
I understand what happened.
Yeah.
Yeah. I'm dead ass.
You're enjoying that graphing
I love graphing.
Graphing!
Wait, so in order, wait, so it told us to find the length and the width, right? So,
Yeah, what did we find?
We found the,
Yeah, just an FYI, guys, we're not done.
yeah, we're not done. We've still only found one part.
We have found two
The
possible
whole damn time.
X's.
We have the exact X and we also have the counter Y. We're not done. X and Y. Y is line length limit, yeah.
Does that work?
Yeah. So we found X, right? Which
Two
is
possible X's.
Which is your width, your length.
So what do we need to get? Some Y's?
Yeah, we get some Y's. So we just plug those into the Y's to get the possible Y's? Or for the 10 minus X?
Well, you know what? Let's plug it in.
And what we're going to
If we plug in a 3 in here,
Yeah.
that would be minus 6, right?
Yeah. Wait, 1 minus 6. Oh,
2
never
times 3 is 6?
Yeah, never mind.
So I've got 2Y is 14,
Y.
which means that Y would be
7, or possibly 7.
possibly 7. But if you do the other one, you're going to get possibly 3.
Yeah.
So that at that point you say, well, it simply is going to be a 3 by 7. Okay? Because it doesn't matter how you swap them,
It's gonna be
you're going to get the same thing back.
Yeah. Okay. So it's
But yeah, don't get to that point and make the assumption that
we're done.
you're done. You have to make sure you go back and no. Sometimes you feel like it. All right, let's move on. I think that might be it. Yeah.
No, I'm
Yeah, we're done.